2.9. We're going to be looking at inequalities. And we've talked a little bit about inequalities before, but now we're going to review them again. When we look at inequalities, we have greater than, less than, greater than or equal to, less than or equal to. And when they go on the number line, depending upon what they are, they either get parentheses or they get square brackets. So strictly greater than, strictly less than, these on the number line get parentheses. Greater than or equal to, less than or equal to, those, when you put them on the number line, well, they get square brackets. And positive or negative infinity, they always get parentheses. So these are just facts that we need to remember. So what we're going to look at first is we're going to review how to actually graph these and write our answer in interval notation. And then once we've learned how to do that, then we'll learn how to solve inequalities. Now, how we graph these is we need to make sure that our variable is always on the left. And so I'm going to give you this, and we're going to graph it and write it in interval notation. So I'm going to have you graph this, and I'm going to have you write it in interval notation. Now, here's the key part that we need to make sure. We need to make sure that our variable is on the left-hand side. Always on the left. If it's not on the left, you need to make sure it's on the left. So is our variable on the left-hand side? Yes. Now, which way does it point? Okay, it points to the right. So that's the way we're going to be shading and graphing. Now it's greater than or equal to, so that means that we get square brackets. So here we are at 5. We're going to use a square bracket. And it's pointing to the right, so we're going to be shading out to the right. Now, where does it go to? Okay, if it goes out to the right, it goes out to positive infinity. Because this is positive infinity. This is negative infinity. Now, what is this going to look like in interval notation? Well, in interval notation, it's going to look like this. In interval notation, it's going to be 5, and it goes out to the right, so it goes out to positive infinity. So in interval notation, it would be square bracket 5, comma, positive infinity with a square bracket, with parentheses. Infinity always gets parentheses. Let's do another one. What about this one? X is less than a negative 4. If I was going to graph this, we come out to our line and we put our negative 4. Now, which way is it pointing? It is pointing back to the left. So that's the way that we're going. Are we going to be using square brackets or are we going to be using parentheses here? We're going to be using parentheses, and it's going back to the left. Now, if it goes back to the left, what is that going towards? Negative infinity, right? So what would my answer look like now in interval notation? Okay, in interval notation, in interval notation, it's going to be negative infinity, comma, where does it go to? Negative 4 with parentheses. So that's what it would look like in interval notation. And they're as the same number in interval notation as they are on the number line. Let's do another one. what would this one look like if we were to graph this one? Okay, now this is what's called a double or a three-part inequality. Well, we find our two numbers. We're at -3 and we're at +5. At the -3, are we going to get now brackets or are we going to get parentheses? At the -3, let's look here and see what we've got. We have a bar underneath, so it's less than or equal to, so we're going to use square brackets at the -3. And what about at the 5? What does it get? Parentheses. So where's my answer going to be at? In between the two. And so in interval notation, this looks like -3 with square brackets. And where does it go to? 5 with what? Parentheses. Is everyone okay with how we graphed those? What do we need to do when we graph these? Here's where we make sure we're on the right track. Make sure that your value of x, your x is on the left-hand side. Now, which way it points is the way that we shade. But your x has to be on the left. So we always put the x on the left. If it's on the right, you'll make a mistake. So you have to move it to the left. So make sure x is always on the left. That's why I solve things and always put it on the left. So when we do the inequalities, it's easy to see. It's pointing, in this case, back to the left. So we shaded back to the left. This one up here, it was pointing where? To the right. So where did we shade? Shaded the right. That's the easiest way to remember these, is look at the way that it points and shade in that direction. Now we're going to be solving a few of these. And when we solve them, here's one thing that we have to remember. When dividing by a negative, flip the inequality. So it's kind of like when we divide a negative by a negative, that makes it positive, right? That changed the sign. When we think about inequalities, the same thing applies. When we divide by a negative, we flip the sign. We also have to flip the inequality symbol. So whenever we divide by a negative number, we have to also flip that inequality sign around. So let's now solve a few of these. So we're going to learn how to solve a couple of these. Let's look at something that's pretty easy to solve. How about we look at question 47? And this is on page 193. These aren't applications, so I'm just going to write them down. And if you want to go to your textbook, you can. I'm just going to write it up on the screen here, either way. And then we've got the -9. So we're going to solve this the same way that we would solve an equality. Now, the only thing that we need to make sure of is that the variable, in this case it's an r, is always on the left, never ever on the right. So when we finish, it has to be on the left. So we're going to solve this the same way that we would solve any other equation. So we move that 3r over, just like we always would, and that makes it then a 2r plus 1. And the right-hand side now is a -9. We'll move the 1 over, nothing new. 2r is greater than or equal to a -10. What are we now going to do? We're going to divide by a 2. Are we dividing by a -2? No, we're dividing by a +2. If you divide by a positive number, that is not going to flip your inequality. The only time you ever switch it is when you divide by a negative. We divided by a +2, so it stays the same. And -10 divided by 2, that makes it a negative what? 5. Is the variable on the left-hand side? Yes, it is. Let's graph this now. So we have our -5. Which way does it point? It points to the right. Brackets or parentheses now? Yep, square bracket. Why? Because strictly greater than, greater than or equal to, less than or equal to, those get the bracket. So we're going to use a bracket. We're going to shade out to the right. Now, where does it go to? Positive infinity. So what does that look like now? In interval notation. Well, it looks like -5, comma, positive infinity with parentheses at the infinity. Is everyone okay with that? Yeah, no problem there. Where students make a mistake is they get confused with inequality. The easiest way to remember is make sure your variable's on the left. Okay, whichever way it points is where you shade. That's it. Let's look at another one. How about question 54? And they're going to be solved the exact same way we solved the others, so nothing new here. It's done the exact same way. So question 54. Minus 4w plus 12 plus 9w is greater than or equal to w plus 9 plus w. So, where do we begin? Well, we treat it like as an equal sign. If this was an equal sign, what would I do? Before I move things across, I would come up here and I'd say, well, those can go together, can't they? Right? So simplify the left side, simplify the right side first. So those can go together. 9y minus 4y, that makes it, w, I mean. So that makes it 5w plus 12. What about the other side? W and another w, that makes it a 2w plus 9. Now what are we going to do? Move the 2w over. Nothing new. 5 minus 2, that leaves you with the 3w plus 12. Move the 12 over. So 3w is now greater than or equal to 9 minus 12, that makes it a minus 3. We'll divide by our 3. Do we switch the inequality symbol? No. Why not? You're not dividing by a negative number. You're dividing by a positive. So it stays the same. There's our w, greater than or equal to negative 3 divided by 3. That makes it a negative 1. Okay. On the number line, here's my negative 1. The variable is on the left. Needs to be on the left, and it is. Which way does it point? To the right. Brackets or parentheses? Square bracket at the negative 1. And where does it go to? Positive infinity. So what would it look like in interval notation? Negative 1 with the square bracket, comma, infinity with what? Parentheses. Okay, let's do a couple more of these. I'm going to try to find one where the inequality will switch around. And let's see here. Okay, question 63. This one should make the inequality flip around. We're going to look at question 63. I believe this one will make us flip the inequality symbol. I want to at least pick one of these. So question 63, this one also has fractions in it. So it's a good review for the fractions. So 2/3 times p plus 3 is greater than 5/6 times p minus 4. Okay, so what do we do first? It's a good review for these fractions. First thing we do is we distribute through. Parentheses have to be done first, then we'll clear our fractions. So distributing through, that is a 2/3 p. plus, we're just going to go ahead and multiply. We're going to write this 3 as a 3 over 1. 2 times 3, that makes it a 6. 3 times 1 is a 3. And you could write that as a 2. It doesn't matter because we're going to get rid of that fraction in just a moment anyways. And then on the other side, what do we have? We have 5/6 p, and then that's going to be over 1. We've got a minus. Okay, 5 times a minus 4, that's a minus what? 20. 6 times 1, that's a 6. Now, how do we clear the fractions? We have a 3 and we have a 6. So what do I need to multiply everything by to clear out these fractions? 6. And let's remember how this works. What do? Divide by the number down below, right? Multiply by the number on the top. So 6 divided by 3. 6 divided by 3 is a 2. Times 2 makes it a 4p. 6 divided by 3, that's a 2. Times the 6, that makes it a 12. 6 over 6 goes away, makes it a 5p. 6 over that 6 goes away, makes it a negative 20. Now we're going to move that 5p over. Nothing new. We've done this many, many times. So that leaves you with a minus p plus 12 is greater than a minus 20. We'll move our 12 over, and this is where we have to work with the inequality, and we're going to divide by a negative. So minus 20 minus 12, that makes it a minus 32, doesn't it? Okay, now, we haven't done one of these before, but what happens when we divide by a negative? Switch your signs, right? So you also flip the inequality. So we divided by that negative 1. Negative and negative makes it a positive p. Switch the inequality. Negative and negative makes it a positive 32. So whenever you divide by a negative, you're going to have to switch the inequality. So we did that on the number line. Here we are at 32. Which way is it pointing? It's pointing to the left, so that's the way we're going. Brackets or parentheses at the 32. Parentheses, and it goes out to negative infinity. Now we write it as it is on the number line. So negative infinity is first, comma, 32, and it gets a parentheses. Okay, let's look at another one. How about we look at 68? Okay, question 68 here. 2z minus parentheses 4z plus 3 is greater than 6z plus 3 times z plus 4. Okay, so there it is. Right, now this is going to behave exactly like all the others. First thing we always need to do is get rid of our parentheses. So the first set, we have a negative here. So I'm going to push that through. And the other side, I push through that 3. So distributing through, I get 2z minus 4z minus 3. On the right-hand side, I have 6z plus 3z plus 12. Nothing new. What do we need to do? Before we move things across, what do? Combine. So let's see what we can combine. 2z minus 4z, that makes it a minus 2z minus 3. On the right-hand side, we have a 6z and a 3z. That makes it a 9z plus 12. Not much to these as long as you're careful. We're going to go ahead now and move that 9z over. And that's a minus 11z minus 3 is greater than 12. Add your 3 to each side. So minus 11z is greater than 15. What's going to happen when we divide by negative 11? Very important that we notice my inequality symbol is going to flip. So now we have our z. We're going to flip our inequality symbol. Why? Because we divided by a negative. 15 divided by negative 11, well, that makes it a minus 15 over 11. It's on the left, which is what we want. Which way does it point? To the left. The way it points is the way that you shade. So that is a minus 15 over 11. It's pointing to the left, so that's the way that we shade. And we're going to use parentheses. And where does it go to? Negative infinity. So what does my answer look like now? It looks like negative infinity to, make sure you see the negative sign there, negative 15 over 11. And it also gets what? Parentheses there. So is everyone okay with how I did that? Nothing new. What's the easiest way to remember when to shade? Which way to shade? You get the variable on the left. Must be on the left and positive. And then you look at the way it points. If it points to the... Did I shade it backwards? No. Okay, we flipped that sign there. Why do we flip that sign? Because we divided by a negative. So that made it this way. Now, which way does it point? Okay, when we flipped it, it points to the left. So we shade where? To the left. Now let's look at some double inequalities, or what are called three-part. We'll do a couple of these. And then that'll be it for today, because I need to make sure we get through this part. So just a few more minutes here. Let's look at 108. Minus 7 is less than or equal to 3x minus 4 is less than or equal to 8. This is what's called, I call it a double inequality. The textbook calls it a three-part inequality. We need to solve it, though. What we want is we want the x by itself in the middle. So what do I need to do first? I want to get the x by itself. Now, that 4 needs to go away. So whatever I do to the middle, I have to do to the other sides as well. So I'm going to add 4 everywhere. And then we've got minus 7 plus 4. That makes it a minus 3. We still have a 3x in the middle. And 8 plus 4, well, that makes it a 12. Now, what do we need to do? We need to get the x by itself. So what do you think we should do next? Yep, divide by 3. Okay, and that's going to get the x by itself in the middle. Negative 3 divided by positive 3, that leaves you with a negative 1. 12 divided by 4, that's a, 12 divided by 3, that's a 4. What does it look like now on the number line? We've got a negative 1, positive 4. What do these get? Brackets or parentheses? Square brackets. And there it is. What would your answer look like now in integral notation? It would be negative 4 with square brackets to positive 4 with square brackets, right? That's going to be your answer. Let's look at another one here. Let's look at one where we have to switch the inequality sign. let's look at 120. And this is on page 196. We're going to look at 120. Okay, so if I gave you this one to work out, now this one's going to behave exactly the same as the others. When we divide by a negative, what happens to my inequality symbols, do you think? They're going to switch. They're both going to switch. That is going to change the order on the number line. So I need to get this x by itself. So what do I need to do? Divide everything by a negative 3. When I divide by a negative, that always switches your inequality. So the x is in the middle, and I'm going to go ahead and switch these inequalities. 9 divided by a negative 3. That makes it a negative 3 on the left. 15 divided by a negative 3, that is a what? Negative 5. Now, look at the order of them. On the number line, which one is smaller? Negative 5. So see the order switched because we switched the inequality symbol. So make sure when you put it on the number line that you switch the order as well. So minus 5, and minus 3 is on the right because it's the larger number. And what do these get now? Parentheses. And there's your answer. And what does it look like now in interval notation? Okay, it looks like parentheses minus 5 to 3. I want to do one more, and I've got the sign-in sheet for us to sign here. I just saw it a second ago. Find the sign-in sheet. So here's the sign-in sheet. And this will be our last question. We're going to look now at 123. This will be our last question. Yep, I missed the negative there. Okay, so let's look at 123, and thank you for that. I just wasn't careful. 22, not 23. So 122. We've got minus 1 is less than or equal to 1 minus 5q is less than or equal to 16. So what would we do? First thing, move that 1 over, right? Because that has to be taken out of the middle. And that leaves you with a minus 2. We still have a minus 5q in the middle. And 16 minus 1, well, that makes it a positive 15. What are we going to do next? Divide by our negative 5. Yep, thank you. And when we divide by a negative, what happens to our symbols here? They flip around. Negative and negative makes it a positive 2/5. Flip your inequality. Q is in the middle. Flip your inequality. 15 divided by negative 5, well, that is a negative 3. Now, we flipped the inequality symbol, so we have to flip the order, right? Because minus 3 is the smaller number, and it's on the left. 2/5 goes here. And what do these get? These get both what? Square brackets. And what would your answer look like now? It's going to look like square bracket negative 3 to 2/5, also with what? With a square bracket. Okay. What's going to be your homework? Well, for your homework now, you should be able to do 2.8. You can do them all. And 2.9. There's some applications, but try to set them up. If you struggle with some of those applications, we can go over them. Now, next week, what we're going to do is we're going to be preparing for our exam. We're going to be going over more of these applications in groups together because you have to know how to do these. Very, very important that you understand these applications. So that's what we're going to be doing next week. And that fall